Here is some speed testing on the latest design for the CNC Scrollsaw. You can see that the moving C-frame is now inside the external C-frame and is mounted much more rigidly. The lighter weight should let us get to a much faster stroke rate, and here we achieve 5 Hz controllably and lose steps at 6 Hz. A stepper motor is really not the best motor to drive this kind of load, as we're really just interested in driving at a constant angular velocity, and stepper motors lose a whole bunch of torque as they go faster. I have a brushless motor on the way, and I'll have another speed test when that gets here. Okay, lost steps. Here's a look from the other side that shows the much longer connecting rod that I had before, and in a second I'll show how that can make a fairly large impact on the torque required to drive a crank slider. I spent a very long time trying to calculate the exact torque requirements for a crankside linkage, and it turns out it's fairly complicated. If you're interested in driving a crank slider at a constant angular velocity, you end up with these very large torque spikes and this alternating torque that tries to push and pull the motor as you go around the circle. Here's a plot showing the difference between a true sinusoidal motion and the crank slider for a given ratio of the length of the connecting arm to the crank itself. And if we look at that for a variety of ratios, we can see that before I was at around a 2-to-1 ratio, and now I'm at about a 5-to-1 ratio. And much longer doesn't give you that much smoother results, but going from 2 to 5 seems to have smoothed things out a lot. And one difference when I move away from the stepper motor is that the workpiece will now be moving at a constant feed rate, and the saw blade will be moving at a constant stroke rate. Whereas before I had the motions linked, as seen on the right, where the workpiece was only moving on the downstroke of the saw blade. This is the ideal motion for the saw blade, as that's how its teeth are laid out. But when moving at a higher speed, having the X and Y axis move in step like this causes quite a bit of vibration in the entire machine.